Hi, I'm Richard Brown. I'm a neuroscientist at the Exploratorium, and I'm going to show a few tricks with our giant spherical mirror. The giant spherical mirror is a new addition that came in for our reflections show, and it's quickly become one of our favorite exhibits here. It's got some of the best properties of the best Exploratorium exhibits in that it's incredibly simple, no moving parts, and yet it can do almost infinite numbers of things relating to all sorts of different phenomena and appealing to people from preschoolers to scientists. Even people on our staff who've worked here and been jaded by all the best illusions in the world come up and go wow and spend time playing with this. So this is a giant spherical mirror, and a sphere has the property that there's a center of curvature that's equally distant from every part of the surface of the mirror. An easy way to find that is to start a distance back from the mirror, find yourself as a small upside down image, pick one eye, and with that eye just walk straight toward the mirror, keeping your eye in the center of the mirror, and eventually the eye will fill up and expand, and everything you'll see in every part of the mirror will be just your giant eye. And now my head is starting to fill the mirror. I have to duck to get the right height. Close one eye, and the eye goes right up to the other eye, and from this point, everything I see in the mirror is just that one eye, because every part of the mirror from the center of curvature is exactly normal to the line from my eye, and it bounces straight back. Watching the video, what you see is my head in contact or occupying just about the same place as my upside down head. If I keep moving though, I can find the camera, and now if I keep that open eye heading toward the camera and walk straight toward it, you see my face and then my eye filling the entire mirror from where you are. From where I am, I just see a distorted, unclear image of the back, but from where you are, you should see my face covering the whole mirror. And this means I'm now at the focal point of this mirror, which is about half the distance from the center of curvature. So I put an incandescent light bulb at approximately the center of curvature, a little off to the side, and you'll see floating right next to it an image of that same light bulb but upside down. In this shot it might be hard to tell which is the real light bulb and which is the image of the light bulb next to it. The image shows that the visible light is being focused to this point, but it's not just visible light, everything else, including sound, including infrared radiation, will focus there. And infrared radiation transmits most of the heat from an incandescent light bulb. So if I put my hand right where the light bulb is, I feel a lot of warmth, which means I'm getting the heat right here focused onto my hand. So now I'm looking back away from the mirror so that I can see the image on an opaque surface. As I bring my hand in to where the image of the light bulb is, you can see on the palm of my hand the image of the filaments starting to form. And right there is where I feel the most heat from those filaments. If I bring a white card there, you can actually see on a better surface, there's the image of that light bulb and the filament on the back of this card. On the other side, I have the liquid crystal thermochromic sheet. If I bring that in and focus it here, there you can see that that image leaves a heat trace on the liquid crystal. So with the piece of frosted glass, I can image these objects. Here's the tree, and then here actually is a piano that's hanging upside down in our museum. It's kind of dark, so it might be hard to see here. When I'm making an image like this, it means that the light from that object, from all parts of the mirror, bounces right into this shape here. And this object is also reversible. So if I were to send light out from this point to all parts of the mirror, it would wind up back at that same object, which is the upside down piano. I can illustrate that with just a single 1 LED flashlight. Without the glass, I still see the image of the piano right here. And if I point my flashlight on that, I'm actually illuminating the piano. And even as I move my flashlight to point to different directions of the mirror, the light is bouncing from all those parts of the mirror and hitting the piano. So this whole time I can see the piano is staying illuminated by my flashlight.